Students often struggle with osmosis graphs, but they're a common topic on both IGCSE and A-level papers. In this question, a student has investigated the effect of different salt concentrations on the percentage change of mass in eggs. Percentage change is an excellent measure to use because it takes into account the starting mass of eggs. It doesn't matter that they'll probably be different sizes to begin with. Remember, all graphs are marked using the ALPS system. Have a look at my profile as I've made another video on that. You're asked to draw a graph in the space provided. They've already written in axes labels, which is why there are only 3 marks available for this particular question. Notice you've got both positive and negative percentage changes in mass, so just like a standard number line, you have the 0 point in the middle and your positive values go up, your negative ones go down. First thing is to set your scales. Remember, you want to take up at least half of the available space horizontally and vertically. We have 6 large squares horizontally, and our concentration goes from 0 to 50 gram per dm cubed. That means we should make each large square worth 10 gram per dm cubed. I would label here in the centre line, but it's fine if you want to label on the bottom instead. It does keep that area clearer. We have 3 large squares above the 0 on the y-axis, and our positive percentage is going up to 7.3. Going up in 2s is not going to give us enough space. Going up in 3s is a total pain. 4s aren't much better. So I'd say let's make each large square worth 5%. We must keep that consistent on the negative part too. I have seen students simply write the values off the table, but if you do that, you're not showing the actual relationship, and the numbers will mean nothing. The values you get in your dependent variable will almost always be irregular, not like the x-axis, but your graph is meant to show the truth of your findings and not just make a straight line every time. So let's finish off our y-axis, going up in 5s on the positive side and down in 5s on the negative side. Let's plot these points carefully. At 0 gram per dm cubed, the egg has gained 7.3%. Each large square is worth 5%. It's split into 10 tiny squares, so therefore each tiny square is worth 0.5% or 0.5. So if we go up to 5 and count up to 7.5, we should mark between the 7.0 and the 7.5 point. We can't just get more precise than that on this graph, and that's okay. Next is 10 gram per dm cubed, and that is plus 3.2. So let's start from 0 and count. 1, 2, 3, and 3.2 is just above 3 and below 3.5, so we'll mark that here. Remember that examiners will mark you to within 1 small square, so as long as it's somewhere between the 3 and the 3.5, you're fine. Next is 20 gram per dm cubed, and that's very close to 0 change in mass. It's more than 0.5 though, so let's make sure we put it just there. Now we're getting to the negative values. 30 gram per dm cubed is minus 2.5%, so we'll count 1, 2, and 2.5, and there we go. 40 gram per dm cubed is minus 6.4. Let's go from minus 5 and down to 6, and then 6.5, and it is just before that. Finally, 50 gram per dm cubed is minus 10.8%. It's lost a lot of mass there. We go to minus 10 and then just over 1 small square beyond. Because the axis is quite far from where the point needs to go, I'm using a ruler to make sure I get it into the right place. Now we have all our plotted points, we can see it's a pretty straight relationship. We'll be able to draw a straight line of best fit rather than bothering with a curve. Please always use a ruler for a straight line, don't just join the dots. A line of best fit describes a relationship, giving you a visual average that accounts for some of the experimental error that is inevitable in every practical. So don't worry about getting every point in there. Plenty of lines of best fit don't hit any of the points plotted. Just remember that whatever points you miss with your line should be evenly spread around the line. As you can see, I've got 2 below and 2 above the line on this particular one that I've drawn. But there is a lot of variation in these that is allowed. Now, what's the point of this graph? Most exam questions that ask you to draw a graph like this will then ask you to predict the concentration of the cell sap in the egg. Now, the egg has been losing mass at high concentrations and gaining mass at low concentrations, all because water moves down a water potential gradient. So we look for the point where the change in mass is 0. Okay. So that's our point there along the 0 axis, and then in concentration that is 20, 21, 22 gram per dm cubed. That means if there is no change in mass, that must mean no water is going in or out, and that must be because the water potential inside and outside the cell is equal, and the concentration of the solution is equal to that inside the egg. 22 gram per dm cubed must be the concentration of an egg. If you have any questions or topics you want me to go over, drop me a comment and I'll see what I can do. Cheers.